Hello, welcome back to Chapter 9, Section 9, the Quadratic Formula, and I'm doing problems on page 657. For these problems, 24 through 29, the directions just say solve. You have the choice for which method you are going to solve. And for our purposes, for the summative for the section, the directions are always going to say solve using the quadratic formula. For all these solving, it's going to tell you to use the quadratic formula is what I mean. For these, we're just trying to get into the idea that if you are not specifically told the method, that you can use whatever method that you're going to want, that you think is going to be easy. So that's really the main idea. What I'm going to be using for these is discussing what I think is going to be easy. So remember, factoring and graphing do not always work, but they're usually easier. And I'm going to leave out the graphing for this one. So I'll be talking about should I use factoring. Square roots only work, section 9.7, when I just directly use square roots, only work if I don't have that x term. So if I look at my examples here, I'm not going to be able to use the square root. However, I can use the square root if I first complete the square and make a perfect square trinomial. So what I'm going to do for this video is, if I can do it by factoring, I'll do it by factoring. If I can do it using the quadratic formula, if I can't do it by factoring, I'm going to use the quadratic formula. Okay? So let's look at problem number 24. Can I factor? What two numbers multiply to give negative 12 but add to give 1? That's easy. So this is going to be x plus 4 times x subtract 3 equals 0. X plus 4 equals 0. Subtract 4, I get x equals negative 4. X subtract 3 equals 0. Add 3, I get x equals 3. Now, that was factorable. I could factor the quadratic expression, and I was able to get it quickly. So that's an example of when it is able to be factored, when it does factor, I don't know. When it is able to be factored, then you can do this quickly. And to be honest, at some point, especially when you get to like maybe pre-calc, for those of you guys who are going to go on the pre-calc, you might even be able to do that in your head. It's baby steps. As you move further through math, you're going to be able to do more advanced stuff. For problem number 25, I noticed that this is a perfect square trinomial already. And what it ends up, this ends up as what two numbers multiply to give 9 but add to give 6. That's x plus 3 times x plus 3. But I'm going to just modify this one a little bit. Notice that that's the same as that. That's a perfect square trinomial. I could have actually kind of worked with this using square roots. If I take the square root, don't forget plus or minus, forgot to give myself some room there, I get x plus 3 equals 0, so x equals negative 3 twice. Don't forget you get the same answer. Same thing if I had done it over here, I would have had x plus 3 equals 0, so x equals negative 3 again twice. So I kind of used a skill. I didn't really complete the square because I didn't add anything to it, but I used that idea that, hey, I have a perfect square trinomial here, so I can just write it as a quantity squared and take the square root. So that's in our toolbox also. Grab this up next sheet of paper. All right, so now I'm looking at problem 26 and I'm thinking, can I factor this? Well, maybe, but I notice that I've got the 2 in front of the x squared, so that tells me that maybe, well, if I factor it, I'm going to have to use that diamond method. So I'm going to go ahead and use the quadratic formula for this. I don't know if the diamond method factoring is going to be more or less work. As a matter of fact, I think I'm going to try to do both of them for this one, just this one. So let's use the quadratic formula. I get b squared subtract 4ac. This is going to be -1 squared subtract 4 times 2 times -1. 1 plus 8 equals 9. Well, that's good to know. Why is that good to know? That means I could have factored it, because 9's a perfect square. I'm not going to end up with a radical. And I get x equals, gosh darn it, that one out of the way so I don't pick it up again. X equals the opposite of -1 plus or minus the square root of 9. See, they start out strong and then they die right when I'm writing with them. All over 2 times 2. This is 1 plus or minus 3 over 4. And I'll write it down here, and I'm going to do this mostly in my head. 1 plus 3 is 4. 4 divided by 4 equals 1. And 1 subtract 3 is -2. -2 divided by 4 is -1/2. So I think because I didn't end up with a square root or anything, I think I probably could have factored this one. And let me just double check. I'm just going to do my diamond method real quick. 2 times -1 is -2 over -1. What two numbers multiply to give -2 but add to give -1? That'd be -2 and 1. When I factor, I get 2x squared, -2x, 1x, and -1. So 2x minus 1, x plus 1. Equals 0. And the 1 is the... What did I forget? Oh, hang on a second. Gotta double check something. Did I mess something up? -1, -2x. I think I'm doing okay. I got my sign switched. How did I get my sign switched? I'm checking this real quick. Maybe I got it wrong over here. I got 1 plus 3 over... No, that's okay. So -2, -1. That would have been -2 and 1, -2x. Oh, of course, I'm sorry. +1, -1 there. So this is actually -1, and that's +1. Thank you. That's what happened. You got to double check. So this would have been x equals -1/2, and this would have been x equals 1. So I got the same answers I got over here. Okay. Got to be careful of those signs, guys. For this one, again, maybe I can do it by a diamond method. Believe it or not, this is a perfect square trinomial, so factoring this is going to work. And I can also use the quadratic formula. How do I know it's a perfect square trinomial? Because this is 2x times 2x, and this is 1 times 1. So this is actually 2x plus 1 squared. And when I take the square root, I get 2x plus 1 equals 0. Subtract 1 divided by 2, I get x equals -1/2. So if I'd factored it, I would have ended up with 2x plus 1 times 2x plus 1. Since those two are the same, that gives me my perfect square. You could also use the quadratic formula. And I said I was only going to double it up with that one, and here I am lying to you. I'm sorry. I get -4 plus or minus... Sorry. I was going... I'm breaking my method I'm using. First, find the discriminant. I get 4 squared, subtract 4 times 1. That's going to be 16 subtract 16, which equals 0, which tells me that I get only one real solution. But remember, I always get the same. If that happens, I always get 2, so I would get this twice. And my quadratic formula is going to be -4 plus or minus the square root of 0 all over 2 times 4. And this is why this is why it looks like I only get one answer, because positive square root of 0 and negative square root of 0 are both 0. So this is negative 4 plus or minus 0, which is just negative 4 over 8. And when I reduce, I get negative 1/2. So whether you factor, complete the square, or use a quadratic formula, all of these should work. Of course, if it can be factored. All right, so for this one, maybe it can factor. I'm not quite sure. I don't think it can be, but I'll find out. I'll be wrong. So I'm going to start off by the quadratic formula. So I get 1 squared, because b is 1. I should write that. A equals 2, b equals 1, c equals negative 7. Subtract 4 times 2 times negative 7. That's 1. Subtract 8 times 7 is 8 times negative 7 is negative 56. And I get 1 plus 56, which is 57. What does this mean? I don't know what the square root of 57 is. So my solution, this cannot be factored. My solution is going to have a square root in it. So I get the opposite of 1 plus or minus the square root of 57 divided by 2 times 2. And this is where I would probably grab a calculator, but I'm not going to, because later in Algebra 2, we're just going to stop right there. This is actually okay, believe it or not, leaving it like that. Finally, for problem number 29, let's put it in standard form. I'm going to subtract 9 and move it over to the other side. So I get 0 equals 2x squared plus 3x subtract 9. I don't think this can be factored. I'll find out if I'm wrong if I get a perfect square. I did not get a perfect square there, so I knew it couldn't be factored. And actually, you can check this too. 2 times negative 7 is negative 14. And 1. Say, all right, what two numbers multiply to give negative 14 that add to give 1? I can't think of anything. Negative 14 is negative 1 times 14, negative 2 times 7, negative 7 times 2, and negative 14 times 1. Nothing adds up to 1. So no, it cannot be factored. At least it cannot be factored the way we know how to factor. I think this one, same thing, but we can try. Actually, I can check right here. 2 times negative 9 is negative 18. What two numbers multiply to give negative 18 that add to give 3? Hey, guess what? I think that maybe this one could be factored, because I think you would get 6 and negative 3. Right, so maybe I'm wrong. I didn't recognize it. See, that's why you have to test these things. Let's do the quadratic formula anyway. I get 3 squared subtract 4 times 2 times negative 9. This is 9 subtract negative 8 times 9 is 72, so negative 72. And 9 plus 72 is 81. Okay, so I know it could have been factored because I got a perfect square here. I get x equals the opposite of b, which is 3, plus or minus the square root of 81. So close. I'm almost done with this video. So close. All over 2 times 3. This is negative 3 plus or minus 9 all over 6. And negative 3 plus 9 is 6. 6 divided by 6 equals 1. And negative 3 minus 9 is negative 12. Negative 12 divided by 6 is negative 2. So guess what? We could have factored that. If I'd start off with my diamond method, 2 times negative 9 is negative 18. 3, that would have been 6 and negative 3. And then, yes, it could have been factored. So it was a good thing that I checked. All right, ask questions in the discussion if you have them.